The electric universe EU model is often misunderstood and misrepresented. Perhaps the most common misconception is that the EU denies the importance of gravity. For example, the popular Wi-Files YouTube channel ran an episode about the electric universe in September 2023, which was more entertaining than accurate, unfortunately. I'm not blaming the Wi-Files as it happens. I enjoy their work, but in researching this particular episode, it seems they had been misled by some of the mischief makers out there. I addressed many of the errors in a previous Thunderbolts Project program. The first part of the Wi-Files headline read, quote, "Gravity is a lie," close quote. I responded thus: while establishment science works with only one tool in its box, gravity, the electric universe model recognizes that plasmas and electromagnetism play more important, if not dominant, roles on the cosmic scale. Hence the filamentary structure of the universe, now observed via radio astronomy and, more recently and more clearly than ever, by the James Webb Space Telescope. Structure in an electric universe. As a general rule, celestial objects do not form the way gravitational theory proposes. The hypothesized collisions, explosions, and slow accretion processes do not match observation, nor do they work experimentally. Decades of planetary simulations show that gravitational accretion can only achieve an object the size of a pebble. Star formation is equally problematic for orthodox astronomy. In a plasma universe, stars and planets are born in an electromagnetic Z-pinch or Bennett pinch, as originally proposed by the Nobel Prize-winning father of plasma physics and plasma cosmology, Hannes Alfvén. He said, quote, "Important fields of research, i.e. the treatment of the state in interstellar regions, including the formation of stars, are still based on a neglect of Bennett's discovery more than half a century ago. Present-day students in astrophysics hear nothing about it," close quotes. Anthony Parrott, a leading contemporary plasma physicist and former student of Alfvén, has been known to say that, quote, "stars form like beads on a necklace," close quote. Furthermore, this has been observed, as discussed in these previous Thunderbolts programs and articles. The predictive successes of the electric universe and plasma cosmology model stand out. Quote, "The only relevant test of the validity of a hypothesis is comparison of prediction with experience," close quote, Milton Friedman. As plasma physicists also emphasize, electromagnetic forces are exponentially stronger than gravity and scale to cosmic dimensions. While standard cosmology struggles to explain filamentary and spiral structures, invoking dark matter, angular momentum, and extended timelines, the electric universe model finds no mystery here. Such structures are expected in a universe dominated by plasmas and electromagnetic interactions. Alfvén put it like this, quote, "I've never thought that you could obtain the extremely clumpy, heterogeneous universe we have today, strongly affected by plasma processes, from the smooth, homogeneous one of the Big Bang, dominated by gravitation," close quote. Alfvén also described, quote, "gravitational systems as the ashes of prior electrical systems," close quote. Reflecting his view that electromagnetism plays a dominant role on the cosmic scale, as early as 1937, he proposed that our galaxy contained a large-scale magnetic field, and that charged particles moved in spiral orbits within it, owing to forces exerted by the field. Plasma carries the electrical currents that create the magnetic field. While some magnetism is stirred into standard models, little importance is assigned. It is regarded more as a curiosity, and one that is very difficult to model mathematically, much to the chagrin of the theoretical physicists, mathematicians. They conjured up dark matter and dark energy to make gravitational equations work. Yet, after more than 4 decades, these exotic entities remain elusive. It has been argued that traditional empiricism based on observation, hypothesis, testing, and theory has been replaced by mathematics. Adding weight to this suspicion, Stephen Hawking appeared to admit to as much. Quote, "You really can't beat a good mathematical theorem," close quote, he said. The nature of gravity. While gravitational equations predict celestial motions with remarkable accuracy, gravity's fundamental nature remains mysterious. Quote, "There is no model of the theory of gravitation today other than the mathematical form." Close quote, Richard Feynman. To illustrate this point, a little history will help. Isaac Newton is credited with discovering the laws of motion and gravitation and reconciling the force that causes an apple to fall to the ground with those that steer the heavenly bodies. Newton, however, conceded he did not understand the mechanism. Quote, "I frame no hypothesis," close quote, he wrote. He could only describe gravity mathematically, thus bequeathing further research to others. Later, Albert Einstein's general relativity redefined gravity as a space-time curvature, introducing time as a literal fourth dimension. Gravity was no longer a force, but a property of space. Many question this abstract concept, though, with Nikola Tesla famously doubting that space could physically curve. Quote, "Curved spaces must react on the bodies, producing opposite effects," close quote, he concluded. This view mirrors historical debates, such as Ptolemy's epicycles, which could also make accurate predictions while failing to reflect reality. The Ptolemaic model survived for centuries, from 160 AD until Copernicus and Kepler in the 16th century, in fact, largely because it didn't threaten geocentrism and, by extension, the authority of the Church. Quote, "The fact that an opinion has been widely held is no evidence whatever that it is not utterly absurd." Close quote, Bertrand Russell. Although gravitational lensing is oft cited as proof of space-time curvature, simpler explanations, like light refraction, work perfectly well, as discussed in Misconception Part 3, Where is the Math? The standard demonstration of space-time curvature, placing a large ball on a rubber sheet representing the Sun, with smaller balls, the planets, attracted to it, essentially uses gravity to explain gravity. This circular reasoning persists largely unchallenged. The free body problem. Known as the n-body problem to astrophysicists, gravitational models may work fine for two bodies, but they break down or become chaotic when three or more bodies interact over time. This is a big problem, given that there are 9 significant bodies in our solar system, not to mention the many moons that, in turn, orbit some of these. Given the math doesn't work out for 3 or more bodies, the fact that our solar system hasn't already descended into chaos is nothing short of a miracle. As a general rule, of course, science shuns the miraculous, the Big Bang notwithstanding. Again, this reminds us that the door must be left open to other ideas concerning the apparent stability of our solar system and, therefore, the very nature of gravity. Quote, "What causes gravity and mass? These questions still baffle all of us. Rather than the end of science being nigh, we are still near the beginning of the cosmic quest." Close quote. Martin Rees, former Royal Astronomer. There is an important lesson in all of this. While mathematical models may enable successful predictions within certain frames of reference, it does not necessarily follow that they describe reality with the same degree of accuracy. Ironically, Einstein himself probably put it best. Quote, "As far as the laws of mathematics refer to reality, they are not certain, and as far as they are certain, they do not refer to reality." Close quote. Gyroscopes and weight loss. Eric Laithwaite was a British electrical engineer and professor, best known as the father of maglev. He developed the linear induction motor and maglev rail system. In 1974, he gave a famous lecture at the Royal Institution where he demonstrated the apparent weight loss produced by gyroscopes. He further claimed that there is no simple connection between gravitational and inertial mass. Although Laithwaite never used the term himself, many contacted him about anti-gravity effects. He was always cautious in his responses, and yet critical of those who dismiss such anomalous effects out of hand. He referred to them as the abominable no-men. Electric gravity. Mainstream physics holds that electromagnetism and gravity are unrelated because electromagnetism can be shielded, while gravity cannot. However, this assumption oversimplifies the relationship. Both forces diminish with the square of the distance, are proportional to the product of interacting masses or charges, and act along the line between them. Historically, notable pioneers in physics sought to reconcile gravity and electromagnetism. Michael Faraday suggested that all forces might stem from a common origin. Quote, "No terms could exaggerate the value of the relation they would establish," close quote, he summed up. Henry Poincaré echoed this sentiment, proposing that what we call mass might ultimately have an electromagnetic origin. The US Department of Navy Research even appears to support this idea. In 2016, the Navy filed a patent for a mass reduction device utilizing electromagnetic waves. This concept contradicts the standard notion that gravity cannot be modified by electromagnetic influence. Support for anti-gravity is considered taboo because it implicitly undermines Einstein's general relativity theory. The paper refers to quantum vacuum plasma, QVP, as the electric glue of our plasma universe. Tesla's dynamic theory of gravity. Nikola Tesla claimed to have a dynamic theory of gravity, unifying it with electromagnetism. Although details are scant, Tesla saw gravity as a combination of EM waves, in contrast to general relativity. Aligning with the electric universe model, Tesla also insisted on the existence of an ether, which can be thought of as a fine elastic medium or plenum that permeates everything. Quote, Einstein, in his special theory of relativity, postulated there was no medium, called the ether, but Maxwell's theory of electromagnetism requires it, and Sir Oliver Lodge saw the ether as crucial to our understanding. So, Einstein, at a stroke, removed any possibility that he or his followers would find a link between electromagnetism and gravity. It served the egos of his followers to consecrate Einstein's ideas and treat dissent as blasphemy. Close quote. Wolf Thornhill. In previous episodes of this misconception series, we have discussed how the Michelson-Morley experiment is often cited as conclusive evidence against ether theory, a view that is now doctrinal. However, researchers like Dayton Miller have drawn very different conclusions, but these have now been demoted to the memory hole. Science by press release. As concerns about scientific rigor grow, we have seen an increase in public relations exercises reinforcing orthodox doctrine in recent years. For instance, in 2012, CERN made headlines by announcing the discovery of the Higgs boson. A few years later, in 2016, LIGO claimed to have detected gravitational waves, allegedly resulting from the merger of two black holes. Then, in 2019, the first photographs of a black hole were splashed across media outlets. These announcements were coordinated on a scale not seen since the Apollo missions. Consensus scientists who describe black holes as one of the most successful predictions of general relativity choose to ignore the fact that Einstein himself dismissed the idea. In a 1939 paper from the Annals of Mathematics, he concluded that the black hole hypothesis was not convincing and that the phenomenon did not exist in the real world. In Misconception Part 2, Where is the Science?, we explored the black hole hypothesis and questioned the underlying assumptions. The intense activity observed at the center of galaxies is better explained by plasma dynamics, a natural result of the immense electromagnetic forces in these regions. Furthermore, the 2019 black hole pictures were composite. From Universe.com, quote, Makoto Miyoshi, a researcher at the National Astronomical Observatory of Japan, and his colleagues say that the high-energy jet is missing from the EHT photo. Moreover, in their new photo of the black hole M87, in a panoramic view, There is no ring of light in the form of a donut, which means that the photo of 2019 turned out to be false. Close quote. Now let's take a look at claims surrounding the so-called God particle. Playing God. More than $10 billion have been spent on the Large Hadron Collider, LHC, at CERN in Switzerland in the hope of finding the Higgs boson, God particle, on which the Standard Model rests. In the Standard Model, gravity is regarded as a property of mass, of course, and the Higgs boson is responsible for this mass. It should be noted that the term God particle has no intended theological implications other than to hint at its importance. The entity was originally conjured by Peter Higgs, who started out by assuming the existence of a particle that exhibits only mass and no other characteristics. In other words, the Higgs is like no other piece in the puzzle, since all normal matter is composed of electric charges. Interestingly, whimsical dark matter also falls into the same mass-only, non-baryonic category. But how can a massive particle exist without charge? What is its structure? Does this underline the problem inherent in leaving physics to mathematicians and the burgeoning disconnect between mathematical concepts and reality? More than 2,100 users from various US institutes are registered at CERN, making the United States the lab's largest user community. As if in tribute to this actual fact, it was on American Independence Day, the 4th of July 2012, and with much fanfare, that the discovery of the Higgs was announced. Given the massive investment in the LHC, I'm guessing they were under pressure to come up with something. After the discovery, the LHC was taken apart and rebuilt with enhancements. More recently, and with much less fanfare, physicists announced that although the LHC had shown hints the Higgs boson was real, experiments in the 145 to 466 billion electron volt range have excluded its existence. Dmitry Denisov of Fermilab said, quote, "We do not see the signal. If it existed, we would see it. But when we look at our data, we basically see nothing." Close quote. In another Higgs hiccup, New Scientist reports that the bad boy is, quote, "refusing to misbehave." Close quote. Quote, "Physicists have spotted the Higgs boson performing a new trick, but one that brings us no closer to understanding the workings of the fundamental particle." Close quote. It seems there may be good reason to be skeptical about the discovery of the Higgs and, by extension, the validity of the Standard Model. All this is not to suggest that the CERN crew are deluded or less than intelligent. Far from it. After all, they've effectively invented a perpetual funding machine. A new, bigger and better version of CERN is planned. From the phys.org article, quote, "Europe's CERN laboratory revealed more details Monday about its plans for a huge new particle accelerator that will dwarf the Large Hadron Collider, LHC, ramping up efforts to uncover the underlying secrets of the universe. If approved, the future Circular Collider, FCC, would start smashing its first particles together around the middle of this century and start its highest energy collisions around 2070. Running under France and Switzerland, it would be more than triple the length of CERN's LHC, currently the largest and most powerful particle accelerator." Close quote. It sure seems that colliders, like black holes, suck up a lot of tax dollars. Gravity in an electric universe. While Fraunhofer has proposed a groundbreaking electric dipole model for gravity, suggesting that gravity results from radially orientated electrostatic dipoles within protons, neutrons, and electrons. In this view, these particles align like tiny bar magnets in response to nearby matter, each forming a dipole due to slight distortions in their structure. Consequently, the dipole-dipole force, which declines with distance, translates to the familiar inverse square law for gravitational forces over larger distances. This framework also accounts for gravity's extreme weakness, which Thornhill interprets as a result of the minute distortion in subatomic particles within a gravitational field. So Oliver Lodge, a respected scientist, once mused, quote, "If a special geometry has to be invented to account for a falling apple, even Newton might be appalled at the complications which would ensue, and really difficult problems are tackled." Close quote. This sentiment captures the ongoing struggle to understand gravity's true nature without resorting to abstract geometries. In 2018, nuclear physicist Raymond Gallucci examined Thornhill's model in his article Electromagnetic Gravity. Gallucci explores the possibility of a unified theory that accommodates both the attractive and repulsive nature of electromagnetic forces and a mathematical framework, concluding that Thornhill's model is plausible. Critics might view the model as incomplete, but standard theories too rely on complex assumptions and hypothetical entities. If gravity functions as an electric dipole force between subatomic particles, then it daisy chains through matter, irrespective of conductivity. This would also explain why gravity doesn't interfere with the electrons essential to daily chores, like making coffee. For a more technical take on energy, mass and light, and the mystery of gravity, I strongly recommend these two Thunder blogs from Matthias Höfner. In summation, the science isn't settled. When it comes to gravity, we need to stay grounded. We still have a lot more to learn. Quote, "I would rather have questions that can't be answered than answers that can't be questioned." Close quote, Richard Feynman. In the next episode of the Misconception series, part 6, we will take a look at another common question. How big is the universe?